Okay, here's the scenario. You're on a Linux system. You know a file exists, but you don't know where it is, or even what's inside of it. How do you actually find it? Let's talk about it. This is a common task that every Linux system admin will face, and so I want to real quickly in this video step through some common tools you need to learn right now. Think of the following questions. Do we search by name, by content, by pattern, or by structure? Linux doesn't just have one way to search. In fact, it has several, each optimized for a different kind of problem. You have locate, find, grep, awk, sed, to name a few. Now, we're going to start with the fastest and the simplest tools, and then we'll move to the most powerful. These 5 commands are the most powerful commands you must know in Linux to be adept at moving through the file system. So really, each command has been developed for a direct purpose. When you want to find files by name, and you want to do it very fast, you would use locate. When you want to find files by location or metadata, you would use the find command. When you want to search inside of files, you would use the grep command. Now, there are other use cases for grep, and we'll talk about those in a moment. But in this scenario, searching inside of files using grep is awesome. When you want to extract fields or columns from structured data, you would use the awk command. And finally, when you need to modify or transform text, especially for automated changes, you would use sed. Let's start with the most simple command and easiest to use, locate. Now, from a previous tutorial on the Linux file system, we created an example txt file. I'm going to cd into the Michael directory, do an ls, and we can see the example txt right here. What I want to do to simulate this scenario is type cd / and hit enter. Now we're at the root directory. So let's say we don't remember where that file is. How would we find it quickly? Well, all we'd have to do is type locate example txt and whammo, there it is. It finds it very fast. The reason it finds this so fast is because all the files are indexed in a database called updatedb. What this means is that locate is fast because it doesn't search, it just remembers. Now, here's the key limitation. It may show files that no longer exist. This means that the database from time to time needs to be updated. Let's go ahead and demonstrate. I'm going to type cd / This will take me back to my home directory, as you can see. And then I'm going to rename this file. I'll use the move command, mv example txt, and I'll call it myexample.txt. Now, example text doesn't exist anymore. To demonstrate, I'll type ls, and as you can see, example doesn't exist. Only my example does. And more importantly, the updatedb database doesn't know yet about this change because it's typically updated by a daily routine or a cron job that runs once a day. So let's type locate example.txt, and you can see that it still says it exists at this location. However, we know it doesn't. So we can force an update of the updatedb location, and we can do this by typing sudo updatedb. Now, this will cause the local database to be updated. Go ahead and enter your password, and it will update now the location of where example.txt is stored. This also will occur after reboot of your local system. Let's type locate example again. And now we can see that it hasn't found example, but it has found myexample.txt. If you're really curious when was the last time the updatedb was executed or the cron job that executes it, you can type the command systemctl list timers and hit enter. And you'll notice that right here is the timer, and we can see that it was last updated just a few minutes ago because I just executed it. The locate command is very fast, but it's limited by how recently the updatedb database was refreshed. So what if you want to truly find something that is not updated yet? Well, this is where the find command comes in. The structure of the command is like this. You have the find, the location, dash name, and the file name. Let's take a look at an example. Here at the command line, I want to find the text file myexample.txt since I changed the name. So let's type find space dot, which means search from where the current directory is, which can be slow if you have a lot of files, by the way. But then this is followed by dash name and then the name of the file. As you can see, it found it very quickly. But let's go ahead and change to the root directory and rerun that command again. Okay, so there is a good deal of information that might seem confusing here. If you're in the home directory, find dot stays mostly safe, right? Because you're searching the current directory. But if you're in a directory that contains protected paths, find will walk straight into issues on other directories. As you can see here, we're seeing a lot of directories based off of the root directory. Now, Linux does not hide these, it protects them, which is why you see permission denied. The find command is dependent on the permissions of the user currently authenticated. So, if you know for sure you need to search across directories outside of your home directory, and you have permission to do so in those directories, then try running this again with elevated permissions using the sudo command. I hit the up arrow on my keyboard to replay the previous command. Now I'll type sudo and hit enter. We'll enter the password, and there we can see it searched from the root directory now and found myexample.txt. As you can see, because of the elevated permissions of the search, all the other warning messages about permissions goes away. Now, keep in mind,
with great power comes great responsibility
and risk. Okay, so the permission issue is important. To search a directory with the find command, you need the execute permissions on that directory and the read permissions on the list of directories. If you don't have permission to enter a directory with the find command, it can't look inside of it. Locate can tell you where a file exists. Find can prove it and touch it, but only if you're allowed. Now, we can also suppress permission errors by discarding the error message. This may not be the best practice in all scenarios because error messages are there for a purpose, but this is how to do it. We'd simply type find, I'm going to use the root directory as the base, dash name, my example.txt. Then I'm going to type the keyword to greater than dev/null. When I hit enter, we can see again it finds the file from the root directory. Now let's walk through what this command does. The key sequence of number 2 and greater sign signifies what are standard errors. And \dev/null is the typical way to discard output that we don't want to see. So by using the number 2 greater than symbol /dev/null, it essentially hides errors. It doesn't fix permissions. We need to be clear about that. So let's be cautious then, because silencing errors is not the same as solving a problem. The best practice is to narrow the search and be more intentional about it. So for example, instead, we know that example is in the home directory. We could type find home Michael, which is my directory, and then type dash name my example.txt. Now we've found the particular file. By the way, searching in this manner is faster. We're not searching across a numerous amount of directories. It's cleaner and it's more intentional. It reinforces thinking before typing. Up to now, we've been searching for files. The grep command is different though. It searches for meaning inside of text. I know I sound like I'm waxing philosophical, and yet that's what it does. But the real power of grep shows up when it's combined with other commands using the pipe symbol. The pipe symbol takes the output of one command and feeds it directly into another. In Linux, output is just text, and text, it can be searched. Now let's put that aside. We'll come back to the pipe symbol in a brief moment. Let's demonstrate what grep does and how to use it. Now, as developers and system admins, we're often going to need to search log files. So here at the terminal, let's type grep error var log dnf5.log. What this will do, it will show us every place in the log file that has the keyword error. As you can see, this searches line by line and then simply prints the matching lines. The search here is case sensitive. So if we modify the search with a capital E, we see now that it highlights where the capitalization of the word error shows. The lines still show the location of lowercase error, but that's not essentially in the search criteria anymore. Okay, let's modify the search and make it case insensitive. We'll add the -I flag and hit enter. Notice now it searches regardless of case. Now, I think it's important to point out that the grep command doesn't care about files. It really cares about lines, but it can be used to find files in a limited way. I want you to think about this question. What if we wanted to search through several files that contain the keyword listen? How would we do that? What we're going to demonstrate is known as a recursive search using grep. Let's type grep-r for recursive, space, double quote, capital L, listen, close quote, /etc, and hit enter. Now, I want you to notice again all the noise from the files that we don't have permissions to. But we also see the files that contain the keyword listen. Now we can apply the same technique of what we did with the find command. Take the command again. We'll type 2 greater than \dev \null and hit enter. Importantly, we have recursively searched the etc directory and looked for files that contain the word listen. So -r means recursive, and it searches one file at a time, and all files in a directory located at the level of that search. And permissions still apply to this type of search. So the key contrast with the find command is find answers where files are, grep answers what's inside of them, or what files exist that contain identified text. Okay, last demonstration before we move on to using the pipe command. You also can combine some flags together. So if you wanted to recursively search and ignore a case, you would type this. We'll just add an I right before and hit enter. Notice I'm still throwing away permission errors in the command, but now I can see both capital L listen and lowercase l listen. I want you to understand something. This is a very powerful tool and command, and you must commit it to memory. So let's talk about the pipe.
The finest weed in the South Valley.
And no, not that kind. In Linux, the pipe lets one command hand its output straight to another. Once you understand this, almost every command becomes more powerful, especially grep. Let's break it down. Let's say I'm looking at files in my directory with the ls command. Now, as file systems grow, and they do, there could potentially be quite a few files in this directory, and this can make it very difficult. So I can pipe the text output from the ls-l command to grep and filter on what I want to see. Let me demonstrate. We have our ls-l, we'll type the pipe command, grep, double quote, .txt, and hit enter. And as you can see, this gives me quite a bit more control over my searching. The pipe symbol here takes the textual output and now makes it receivable to grep for further searching. By doing so, we're not searching files, but now we're searching output, and that's powerful. Okay, let's say we're needing to filter down the file list in the var log directory to find logs pertaining to the cron command. We could type ls-l /var/log, and if we hit enter, we're going to see a lot. But if we add the pipe command to it, grep space double quote cron and hit enter, now we only see the 3 log files related to cron that we want to look at. This allows us to see with greater fidelity what we're currently looking for. Now, you can pair the pipe symbol with other Linux commands as well, and then filter those results with grep. You could do the same with the find command or the locate command or any number of Linux commands that return textual output. Let me give you one more real-world example of using pipe and grep together. As a Linux system admin, you might have to locate a particular process and either kill that process or determine who started it or look at the memory or CPU usage. So when we're looking at processes, we'll typically type ps aux. And as you can see, there is quite a bit going on here, more than what I care to search for. But although this gives me an exhaustive list of processes and their PIDs that we see here, this information is very useful, especially if I want to kill it. But as you can imagine, this is also quite overwhelming at times. And this is where the power of pipe and grep come in. If I type ps space aux pipe grep and then sshd, now I can filter on particular SSH logins that exist. Here's the thing. Once you learn grep, every command becomes searchable. You can use the pipe command to send just about anything to it. So I want to give a list of a few flags here that you can use on the grep command. And again, these can be used together as long as you understand what they're doing. You can use the -i, meaning we could do pipe grep and search for, say, something like person's name. You can use -n to set line numbers. You can use the recursive symbol, which will recursively go through folder structure. It won't particularly work really well here with this. And you can also use what is called an invert match, which basically will show every other item except what we're filtering on. This last flag -v really is an interesting one. It allows you to, as I said, invert the search. So as I typed ps aux pipe grep -v sshd, it displays everything except what was filtered on, in this case the SHD, which means it excludes SHD from the search. Hey, let's do a quick recap just for a moment. So far we've looked at locate, which examines names. The find command looks at file systems. Grep looks at content and output. And I think this means that we're ready for the awk command. Now, if we were to contrast grep and awk, we would see that grep tells us which lines matter And awk tells us which parts of those lines matter. If grep helps you find the right lines, awk helps you extract the right parts of those lines. Okay, so I have a few extra text files on my system right now, and we can see them if we run the ls-l command. These are fairly easy to recreate if you want to follow along, but I'm going to go ahead and run the command cat users.txt. Now, the contents of the user text file basically is a list of names, their roles. What I want you to do, though, is I want you to think of awk this way if we're looking at this file. Awk will read the input line by line and then split it into fields and let you act upon those fields. So let's say we have a much larger file than our typical users.txt right now, for example, and we want to see the first column of that file. How would we do that? Well, in awk, it's quite simple. We type awk, single quote, curly brace, print, $1 for the column we want to see, close curly brace, single quote, and then the name of the file. When we hit enter, you can see that it quickly represents the first column out of that file. So the $1 represents the first column. And of course, print says, give us what I'm specifying here, that column. And as you might assume, the columns are split on white space. So we could also type the same command again. We could add a few extra columns by doing comma, $3 for the third column. And now we see the names as well as the PID numbers for those columns. Okay, fun fact. If you're like me, you might have been wondering, what does awk stand for? Well, it's an acronym derived from the first letters of the last names of the 3 authors who created it. Alfredo Ahal, I don't know if I pronounced his name right, Peter Weinberger, and Brian Kernighan. Yeah. Anyways, if we type ls-l and we pipe this to awk, single quote, curly brace, print the 9th column, close curly brace, single quote, we're going to see just the names of those directories or files in my home directory. Basically, if output has columns, awk can work with it. Another exciting feature of awk is pattern matching. So let's say we only want the columns that have matching admin in the file. How would we do that? We would type awk, single quote, \admin, then we would type the curly brace, print, space, $, the column we want to see from that collection, close curly brace, single quote, and then the file we're interrogating. And as you can see here, it prints just the first row and the first column, finding that person who has the admin capability. I can highlight it up here if this makes more sense. So we can see the pattern is passed onto the action, much like grep, but here it's field aware. We can also change the field delimiter in awk because sometimes it might not be a space. It could be a separate, different character. If we run cat etsy, PSSWD, we're going to see various users on the system. I typed that command wrong. Let's type this again, cat etsy, PASSWD. There we go. You'll see the various commands on the file system. And you might notice that the field delimiter here between these columns is the colon. So let's type awk -F for field delimiter, and then the delimiter we're going to use, the colon, space, single quote, curly brace, print, $1, close curly brace, dash, and then the location of the file. And here we can now see just the users as it relates from the first column. So using the -F flag followed by a colon, we're changing the field delimiter to a colon instead of the default delimiter, which is space. Now this ability is significant because this means that you can practically use awk anywhere, and this is why awk is found in just about all Linux scripts. Okay, we're going to do one more example, and this will blow your minds with awk. You can do some mathematical calculations. Are you guys ready for this?
Are you ready, kids?
I have a basic file called grades.txt, and you can see it here. If we run the cat command on grades.txt, you'll see some basic information like the grades for Pat, Sandra, and Chris. If we type awk, single quote, curly brace, sum equals the column name 2 plus column 3 plus column 4, and then we go on to type avg equals sum divided by 3. You'll notice I'm putting a semicolon to terminate the end of each command, followed by print $1, comma, double quote, average, colon, close quote, comma, avg. We'll put a curly brace, then our single quote, and then the file. Notice what happens. Boom. That's crazy, right? Awk is awesome. Now, let's break down what we did here, okay? The $1, $2, etc. refer to the first, second, and subsequent fields, columns of each line. The actions are within the curly brace, are performed for every line in the file input. And there's tons more to learn here with awk. And if you want to dive deeper, type the phrase man awk and hit enter. And this will show you all of the various commands within awk that you could use. Awk is a full programming language, but most admins use 5% of it, only 95% of the time. So we're now ready to look at the last command line tool in this video. If awk extracts and analyzes text, the next one, sed, allows us to change it. Enough said. Let's jump in. Sed is a stream editor. It modifies text as it flows through a command without opening the file in an editor. You don't use sed every day, but when you need it, nothing else works as well. Now, the table I'm showing here shows you some of the core things that you can do with sed. I recommend that you pause this part of the video and look at the flag or the pattern related to each part of the command. When you want to replace text, you can use an S pattern. When you want to replace all matches in a line, you would use the global, the G pattern. When you want to delete a line or lines, use the D pattern. When you want to print specific lines, you would use the -N or the -P flag. And when you want to edit the file in place, you would use the -I. If you only remember one thing about sed, remember substitution. All right, at the command line, let's type sed space, single quote, s/pat/patty, /, single quote, and then the name of the file. Notice it immediately outputs the proposed changes. I say propose because the command line outputs the changes in text to the screen. However, it hasn't changed what's on the original file. If I run cat grades, you can see that those changes are not made yet. However, If I use the I flag with this, it will tell sed to edit the changes in place. So let's rerun the command. We're going to add the -I flag and hit enter. Now, if we run cat grades again, we can see that it's changed Pat to Patty. I think it's important to emphasize that this -I flag is powerful and, if not dangerous, if you're not careful. Always run without the I flag to verify your output first. So let me be clear here. If you need to interactively edit text files, use an editor. Sed really should only be used for automation. We've covered a lot in this video. A good rule of thumb with these commands is it's probably best to start with the simplest command, like locate first when searching in Linux, and then escalate when needed. Think of this progression. Keep this in mind. Do I know the file name? Use locate. Do I need accuracy? Well, maybe the find command. Am I searching for content? Use grep. Do I need structure from the text return? Use awk. Do I need to automate changes, like change information? Use sed. If you made it this far in the video, I'd like you to leave me a comment. The comment is, enough said. I know that was awkward. Okay, I can't help myself. I hope you can find it in your... I know, I'm milking this one too far. But seriously, leave me a comment and be sure to like and subscribe. It really helps a lot. So listen, in the next video, I want to tackle some basic tools for file editing in Linux, like Vim and Nano. Be on the lookout for that video. I hope to have it ready soon. Until next time, blessings.